Assalamualaikum warahmatullahi wabarakatuh. My name is SYAFIQAH binti KHAIRI. My matrix number is 196810 and this is my partner TUAN SYAZWANI binti TUAN ISMAIL. My matrix number is 196881. So today we are going to present Haccp plan and our topic is aflatoxin in pasteurized milk. So this is the phyla table. The fact is biological contamination of aflatoxin in pasteurized milk. So our ideas is animals are exposed to this mycotoxin by consumption of feeds that contaminated with mycotoxin producing months. So how aflatoxin in the milk could be discarded? We come up with the action plan, which we conduct a hazard analysis and develop a hazard plan to prevent this issue from occurs. So this is the company that we choose, which is Dutch Lady. Dutch Lady established in 1963 in Petaling Jaya, Selangor. It is one of the leading dairy company in Malaysia, the subsidiary of Friesland Campina, one of the world's largest dairy cooperative, and they strive to continue providing better nutrition for the nation and to continuously help build a stronger Malaysia for generations to come. This is the organizational chart, which leads by managing director, and under operations director will be Haccp team. The Haccp team leader is quality control manager, and the others is Haccp team member, which is head of manufacturing, new product development manager, and manager site engineering projects, operation manager, and quality manager. This is the management policy.
First is code of conduct. Dutch Lady is guided by Friesland Campina Compass, and they guide their business behavior and their employees in all business activities. Next, they do business on this business. Any improper of the owner's way of doing business are strictly forbidden in Dutch Lady. Next is speak up. They allow an employee to address any concern regarding non-compliance with compass to the company. And the last one is business practices for business partners. Business partners are to conduct business in the manner set out in their business practices for business partners policy.
This is the factory layout, which will be described more in plan schematic. Next is
Haccp team profile. The first is quality control manager. The food safety job role is ensure overall implementation and maintenance of food safety management system. Next is control communication between company and customer to ensure customer requirements are met, and ensure production system running according to GMP requirements and without affecting food safety. Next is operation manager. He will establish of contract with the farm for raw milk delivery, verification of quality, certificates for raw milk, and record of the non-conformities and archive. Next is manager site engineering projects. Basically, it will verify technical stage of the equipment, construct materials, and ventilation equipment. The new product development manager, also one of the member of Haccp team, her job role is product design and development. Next is head of manufacturing. His role is production processes, pest control, and garbage and waste. And the last one is quality manager. The role is product description, product contamination,
and hazard, hygiene, cleaning, and disinfection, and laboratory tests. This is the Haccp scope. Dutch Lady has 9 categories of milk. Some of them is growing up milk, UHT milk, and pasteurized milk. The production line of Dutch Lady must make sure the awareness of the production line applies to Haccp. Factory arrangement is very crucial for the operations and productions of the final products, and they must maintain the quality of the products.
They use IMSAFE policy for food safety policy, which is intervention, ensuring management system, supervision, academic focus, and engagement. Next is food safety objective. First, quality control. Their target to ensure no microbes detected. Deal will be checked monthly by Haccp team leader. Next is customer feedback. Then their target is to receive at least 2 complaints about food quality and safety, and this will be checked by quality manager yearly. Next, food safety training, at least 10 hours per employee. The time frame is yearly and checked by Haccp team leader. The last one, production plan achievement more than 80%. Person in charge is operation manager and will be checked yearly.
This is the product, which is pasteurized milk. The product is description and intended use. The product name is pasteurized milk. Raw ingredients is raw milk. The microbiological limits is total plate count must be 1 times 10 power 5 colony farming units per gram, and Staphylococcus aureus is 5 times 10 power 5 colony farming unit per gram. The chemical limits, the pH must be 6.4 to 6.8, and the appearance is no coagulation, clotting and precipitation. The milk must have typical milk odor, not rancid, and typical milk taste, not sour. The process type is pasteurization, which high temperature, short time. The intended use is ready to serve product, may also be used as ingredient in preparing meals. Next is packaging. The packaging is high density polyethylene gallon container with a polypropylene snap-on, screw-off, temper evident cap. Labels are self-adhesive and applied prior to filling. Code date is printed via coding equipment. It must be stored in storage below 7 degrees Celsius. The shelf life is 21 days under proper refrigeration. It for general customer to be sold at hypermarkets, retail shops and wet markets. The labeling instruction is company's name, nutrition facts, ingredients labeling, certified logo, serving instruction, amount serving, expiry date and storage after use. And the distribution and handling, distributed using refrigerated trucks to wholesale and retail outlets.
Next, I will present about process flow diagram that is verified by Haccp team leader. Next, for the process start, for the pasteurized milk, milk is delivered to the site by tankers from third-party suppliers. Raw milk undergoes alcohol, fat, protein, antibiotic test, and pH. Temperature, total salt content, Staphylococcus aureus, and TTC is measured. Temperature should be 4 degrees until 10 degrees Celsius, and the pH should be 6.4 until 6.8. Then the milk will be filtered that pass through a 6.5 millimeter suctionless strainer, and thermalization raw milk is heated to 63 until 67 or 76 degrees Celsius for 15 seconds. For the cool down, milk will rapidly cool down to 5 degrees Celsius or below. For the pasteurization, preheated mixture passes through the plate heat exchanger and mixes hot water to heat. The mixture then passes through a holding tube that constant flow rate to ensure effective pasteurization. Temperature probes and recorders monitor the process to ensure pasteurization conditions are met, which is 83 degrees Celsius for 15 seconds.
Next, milk will be stored in the storage tanks. If notice any variation of the batch composition, the batch will be reprocessed to meet the final requirements. For the packaging of the pasteurized milk, use high-density polyethylene container. The packaging material passes through the UV cabinet and is sterilized. Water are transferred to the filling through the conveyor. The product will temporarily stored on the pallet until complete the palletizing of each pallet with maximum holding time of 45 minutes. And last but not least, the pasteurized milk will be stored in the refrigeration stores and ready for transport. The temperature of the cold storage should be less than 8 degrees Celsius.
This is the plus schematic that show the flow through plant. Firstly, from the raw material receiver to the primary processing, such as pasteurization. Next to the secondary processing with high care such as drying. Next to the packaging line, finished product stock, and lastly loading and distribution. Next, on-site verification. A procedure must be developed to maintain the Haccp system and ensure that it continues to work effectively. 7 principles of Haccp establish the documentation concerning all procedures and records relating to the application of these principles. Haccp is not a standalone system. Good hygiene practice and other prerequisites for food processing as well as strong management commitment are also necessary. Training is another essential requirement for a successful Haccp system.
This is hazard analysis for raw material and packaging material. The raw material is only raw milk. The potential food safety hazard is biological, chemical, and physical. For the biological, presence of Salmonella, E. coli, Listeria, and other pathogens that can cause foodborne illness. For the chemical, is presence of beta-lactams from the antibiotic used to the cow. And lastly, for the physical, is presence of soil, sand, and plastic during improper handling. Then for the packaging is polyethylene terephthalate or high density polyethylene container. For the biological and chemical, there is not identified. But for the physical, it is contain piece of plastic inside the container during improper handling. Next, for the hazard analysis for process step, firstly is receiving of milk for the potential food safety hazard. The biological is microbes such as E. coli, Salmonella, Listeria, and it is not SYAFIQAH. For the chemical, presence of mycotoxins such as Aflatoxin. The justification is inclusion because milk growth in animal feed can contaminate to present in raw milk, which is milk with Aflatoxin M1. It is a CCP. Next, for the physical, presence of sand, soil, and plastic. It is also CCP because the supplier does not clean the raw material well before sending it to the manufacturer. Next process is filter. For the physical, it is CCP because it presence of soil and sand come from farm environment and animals make collection or storage on farm. For the chemical and biological, it is not identified. For cooling process, it in biological, group of such as Pseudomonas, because milk store are not required for temperature. It is CCP4. Next, the next process is homogenization. This process not contain CCP, but for the pasteurization, for the biological hazard, Salmonella and E. coli contain CCP because it is occur during time and temperature are used. Next, for the storage tank, during this process also don't have CCP. Next, during the storage and distribution also did not have CCP because it is not significant hazard. Next for the hazard summary of pasteurized milk. The first CCP is raw milk receiver in biological hazard, which is presence of mycotoxin, which is Aflatoxin M1. The critical limit should be 100. The second CCP is also under raw milk receiver, which is physical hazard, forest matter such as sand, soil, and plastic. So the critical limit, the size of the post should be validated and documented. Next, for the third CCP during filter process and physical hazard, forest matter such as sand, soil, and plastic. Same goes to the same like the receiving of milk. So the fourth CCP is cooling process. The biological hazard is growth of psychotrophic bacteria. So the temperature of cooling raw milk should be 8 degrees Celsius or less. Time of cooling within 4 hours. The last but not least for the CCP is pasteurization, biological hazard for Salmonella and E. coli. The temperature of pasteurization should be 73 degrees Celsius until 77 degrees Celsius for 50 seconds. Okay, the hazard summary plan also verified by hazard leader. Next. Okay, that's all from us. Thank you.